So in the previous video, we have seen the three equations of uniformly accelerated motion. Now in this video, we're going to learn how to derive them. So let's begin. So recall guys, what is the first equation of motion? It is v is equal to u plus at. Here v is final velocity, u is initial velocity, a is acceleration, t is time. So let me show you the derivation. So I'll give the heading derivation. So see, to derive the first equation of motion, we use the formula for acceleration. So recall, what is acceleration? Acceleration is nothing but final velocity minus initial velocity by time taken. So just cross multiply. So we get a into t is equal to v minus u. Take u over there. So at plus u is equal to v. Write it the other way around. So v is equal to u plus at. As simple as that. So this is how you derive the first equation of motion. I repeat, we start by the acceleration formula, v minus u by t, just cross multiply. So at is equal to v minus u, take u over there. So at plus u is v, write it the other way around. So v is equal to u plus at. As simple as that. So I hope the first equation is clear. Now let's derive the second equation. Recall, what is the second equation? S is equal to ut plus half at square. So let me show you the derivation for this. So to derive the second equation of motion, we use the concept of average velocity. So I'll first write down the formula. That is average velocity is equal to total displacement by time. That is total displacement by total time, right? So from here, what do we get total displacement as? Average velocity in total time. So I can say from here, displacement is equal to average velocity into time. That is average velocity multiplied by time taken, right? Now guys, what is the symbol for displacement? S is equal to, now for average velocity over here, because this is uniformly accelerated motion, we can use the other formula. So recall, I taught you a formula for average velocity, u plus v by 2. Is this clear? So whenever we have uniformly accelerated motion, this is how we calculate average velocity. So multiplied by time, right? Now if you notice carefully over here guys, we have s, u, v and t. But if you look at the second equation of motion, we have s, u, t and a. There is no v over here. I repeat, in the second equation of motion, there is no v. That means we have to eliminate v. How do we eliminate v? We already have v is equal to u plus at. I repeat, how do I think? In the second equation of motion, there is no v. That means we have to eliminate v from here. So we'll substitute this value of v over here. So that means s is equal to u plus v. Instead of v, we'll write down this value over here. That is u plus at by 2 into t. And in the bracket, you have to mention why you've done the substitution. You'll say v is equal to u plus at from first equation of motion. So from first equation of motion. Now let's simplify this. So from here we get s is equal to u plus u, that is 2u plus at by 2 into t. So we get s is equal to, now first we'll multiply t inside. So we get 2ut plus at into t, at square by 2. Let's divide. So s is equal to 2ut by 2 plus at square by 2. So what happens? This 2 and 2 cancels off. So from here, what do we get? S is equal to ut plus at square by 2. I can write it as half at square. So see, this is how you derive the second equation of motion. Let me do a recap. We start by the average velocity formula. The first one which we learned. Average velocity is displacement by time. So what is displacement from here? Average velocity into time. Because this is uniformly accelerated motion, how do we calculate average velocity? U plus v by 2. That is initial velocity plus final velocity by 2. Now if you notice in the second equation of motion, there is no v symbol. That means I have to eliminate v. How do we eliminate v? by substituting this value. So from the first equation of motion, we substitute v as u plus at. Simplify, you get your answer. So this is how you derive the first two equations of motion. So I hope this much is clear. Now let me rub this off and then we'll derive the third equation of motion. So now let's learn how to derive the third equation of motion. So first I'll write down the third equation of motion. It is v square is equal to u square plus 2as. So now let's talk about the derivation. So we first of all start from the second equation of motion. Why? There is a displacement over here. How do we get displacement from second equation of motion? So first I'll write down the second equation of motion. That is s is equal to ut plus half at square. And we'll mention in bracket what is this over here? Second equation of motion, which we have already derived. Now guys, if you notice in your third equation of motion, there is no time over here, right? That means we have to substitute the value of t. I repeat, over here there is no time, so we have to substitute the value of t. How do we substitute the value of t? From the first equation of motion. Recall, what is first equation of motion? V is equal to u plus at. So from here, what is the value of t we get? A into t is v minus u. So t is equal to v minus u by a. So this value of t, we're going to substitute over here. So before that, let me mention over here, this over here is first equation of motion. So we have this value of t. Let me box it. It's a long calculation, so I'll start from here. So I'll rewrite this over here. We have s is equal to ut plus half at square. Then I'll write down over here, substituting the value of t. So substituting the value of t as v minus u by a. And what you can do is you can just label this as 1 and you can mention over here from 1. So let's do the substitution. So we have s is equal to u into t. What is the value of t? It is v minus u by a plus half a t square. So a into t square. What is t? V minus u by a the whole square. Now all we have to do is just simplify this. So let's do this. S is equal to u into v, uv minus u into u square by a plus. Now we have a by 2 into v minus u the whole square upon a square. Right guys? So this a and this a cancels off. We get this over here. So s is equal to uv minus u square by a plus v minus u the whole square, a square plus b square minus 2ab upon 2 into a, that is 2a. Right? Now here the denominator is a, here the denominator is 2a. So we'll take the LCM, it is 2a. So s is equal to, denominator now becomes 2a. So 2a divided by a is 2 into this. So we have 2 into uv minus u square plus 2a divided by 2 is 1 into this. That is v square plus u square minus 2uv. So let's open this. S is 2uv minus 2 into u square plus v square plus u square minus 2uv by 2a. So as you can see, plus 2uv minus 2uv cancels off. From here we get s is equal to v square minus 2u square plus u square minus u square by 2a. Is this clear? We'll multiply these two. So we get 2as is equal to v square minus u square. Take u square over there. So from here we get v square is equal to, take u square over there. So u square plus 2as. So it's just a bit more calculations, but it's pretty much the same thing. So let me do a recap. For the third equation of motion, we first of all write down the second equation of motion. If you notice, in the third equation of motion, there is no t. So we substitute the value of t from where? From the first equation of motion. So first write down the two equation of motion, get the value of t from here, substitute here, simplify, you'll get your answer. So this is how you algebraically derive the three equations of uniformly accelerated motion. Later on, when we study graphical representation of motion, I'll show you how to derive the same three equations from a graph as well. As of now, just focus on this. So algebraically, this is how you derive the equation of motion.